Dr. Simon. My name is Jesse M. Speck. I'm from SecureSpace.com. And anyway, one of the things I wanted to ask was so what makes tonight, here we have Jupiter at opposition, right? And if we can go over what makes that one of the best times to see it.
So Jupiter is at opposition right now. That means that if people go out and look around sunset towards the eastern sky, they'll see Jupiter rising in the constellation Virgo, and it'll be visible all night long, basically setting at sunrise. And if they go out with a small telescope or even binoculars, they might even be able to see the larger of Jupiter's moons, the Galilean moons. And the reason this opportunity is so great is because we're at opposition, and that means that the Earth's on the same side of the Sun as Jupiter. So it's our closest point any year to view Jupiter. So it's basically when it's biggest in the sky, and you can get the best resolution.
Okay, so it's biggest in the sky, and that comes up as, you said, once a year, or is it every 13 months or so, something like that?
Yeah, it's just tied to the orbital periods of Jupiter and the Earth, so it's once every 13 months that we reach this point.
Okay, and what I'm curious about is how this, it's a Hubble telescope just took an image of this, and I'm curious as to what the Hubble is telling us about.
So opposition is also a good time for Hubble to look, because that's when it can also get its maximum resolution. And so the Hubble Space Telescope's been looking at Jupiter for the past 25 years. And this particular image, taken just a few days ago, we can see the dynamic cloud bands, all the swirling clouds and colors on Jupiter, of course, and the Great Red Spot. But we also see wave features and smaller storms in the atmosphere. So we're learning a lot about Jupiter's weather, basically, by doing these Hubble observations.
Okay, so about the weather on Jupiter, I'm curious as to what we might know now that we haven't known before. I mean, there was the Voyager trip, for example, two of them, right? We've got Juno out there now. How does Hubble supplement those space probes?
So the nice thing about Hubble is that, first of all, we can look a lot longer than we could with something like Voyager, which just flew by very quickly. So we're getting yearly views right now. And we're able to study these cloud bands on a yearly basis. It's still not as great as a weather satellite, of course, but we can look and see how it's changing from year to year. And we can even look at phenomena like the aurora, because we have access to the ultraviolet light. So we're learning a lot more basically about the timescales on which the clouds change and the details, the high resolution. And we also have the Juno probe there right now. And Juno's interested in the deep interior, the magnetic field of Jupiter, but it's also getting close-up images, and so we can use Hubble to place those into context and kind of see the overall weather at the same time as these really nice close-up views.
Okay, and one thing about this is Jupiter is really large, and the Hubble, you said it saw some wave patterns and some things about weather. Were there any other interesting features that Hubble was able to pick up in this latest sort of photo shoot? Anything perhaps about the Great Red Spot that we always hear about? You're talking about wave patterns. What do people think those wave patterns might mean?
So Jupiter is interesting because it's a gas giant planet. So basically we have weather without the surface like we have on Earth. So we can watch that weather in a different way than what we see here. And the Great Red Spot in particular is a hurricane-like storm. It's actually a high-pressure system instead of a low-pressure system. But we've been able to observe it over Hubble's entire lifetime, and we've watched it change color and change shape. So it's gotten quite a bit smaller and rounder than we first started looking with Hubble 25 years ago. So we're learning a little bit more about what powers it and basically what's driving the weather on Jupiter. And some of these things are very similar to what we see on Earth. So some of the waves that we see in Jupiter's atmosphere are exactly like the ones we have here on Earth. And so it's interesting to be able to study them without having land masses, for example, to see how long they last.
Okay, and with the Great Red Spot, we've heard about, some people have heard about, that maybe it's fading, or you're saying it's becoming smaller and rounder. And you also mentioned that it's a high pressure rather than a low pressure system. And why would that be? Why is it on Jupiter that you have a storm, like here on Earth, right? Storms happen with low pressure systems where the air sort of spirals in. Why that would be sort of the mirror image on Jupiter?
So it turns out on any planet you can have high or low pressure systems. It's just that on the Earth, the low pressure systems seem to form more of these stable storms. But we obviously do have high pressure systems too. They just don't look like this. On Jupiter, we also have both high and low pressure systems. It's the high pressure systems that are nice and round and the ones we recognize. But there are actually low pressure hurricanes on Jupiter as well. And so basically